Here's our fourth question for this week. We were dealing with piecewise functions in September, and now we have an example of a piecewise function. We learned about them so that you could now look at them in terms of limits and continuity and have feel comfortable with the format and what we're looking at. So when we see this piecewise function here, you can see that below 0, for x less than 0, it looks like a parabola opening up. Between 0 and 1, it's a straight line with an upward, fairly steep slope of 2, and then above 1, it's a different parabola. So you can have a kind of a mental image of that, but what we don't really know is, do these pieces look like a half a parabola, a line, and another parabola, or is it more like, are they all connected together? We could look at that and figure it out, but we're going to use limits to figure out that behavior without having to do any graphing or plotting of points. So first the question asks us to find 4 limits, so let's do that. Well, I'll tell you what the whole question is. First we find 4 limits, then we need to find if f is continuous at 3 different points, x equals 0, 1, and a half, and we have to explain why or why not at each of those 3 points. The universal law of homework says that there'll probably be 3 different answers for those 3 points. But we'll leave that alone for a minute. So looking at these limits, the first one is the limit as x goes to 0 from the negative of f, our function. You can think of it as the left limit at 0. So we need to use the function definition here, because as we're coming up to 0 from the negative, that's where x is less than 0. So the limit here is the same as the limit as x goes to 0 negative of that function, which is 1 plus x squared. Unfortunately, we're not going to run into any issues with denominators being 0 or undefined limits. We can just plug in, and we see that the limit here is, well, if x is 0, then it's just 1. Similarly, the limit as x goes to 0 from the positive side, we do exactly the same way, only now we're coming at 0 from the positive side, so we need the second part of our function, which is 2x minus 1, and the limit of that is negative 1 when we put in x for 0. Now if we come at 1 from the negative side, or from the left if you prefer, that's the second part of our function where x is less than or equal to 1, so it's 2x minus 1. When we substitute in 1 for x, 2 times 1 is 2, subtract 1 is 1. And finally, when we come at 1 from the left, we're using that last part of the piecewise function, which is x squared equaling 1. So we found the 4 limits. That should help us with this question. The rest of the question, is f continuous at x equals 0? Well, we figured out these limits here. And when we come at it from the left, it's 1, and from its right, it's not 1. So it's discontinuous at x equals 0. So we would have to say no. It's not continuous because the left limit and the right limit are not the same. I'll write that very quickly. The left limit and right limit are unequal, or not equal. Might be able to hear my cat in the background. I hope that's amusing to you. At x equals 1, we have a different situation. We've got the limit as we come from the left is 1, and the limit as we come from the right is also 1. So the limits are equal, so that is helpful, but we also have to check, is the value of the function the same? And it is. We could check that for both of them, but no matter which piece of the function we look at, f of 1 equals 1 from both sides. Well, sorry, the value of the function is 1. That's the second part of the piecewise function. F of 1 is 1, but it is the same as the equals. So here we can say yes, the limits exist and are equal. Exist and are equal. And also equal to f1, f of 1, which is important. Now, at x equals a half, you can probably guess, because it's in the middle of a continuous piece of the function, that it is continuous. But let's show our work to be sure. We want to know the limit as x goes to a half from the left of f of x, which is, what piece is that function? That's 2x minus 1, which is 0. And the limit as x goes to a half from the positive side is also 0, and f of a half is also 0. So yes, it's continuous there because the left and right limits exist and are equal to the value of the function. So that's the example of continuous, discontinuous, and question 4.